Welcome to another deep dive. Today, we're going to be looking at how neural networks and automated theorem proving can work together.
Well, that sounds fascinating.
It is. Our listeners sent us some research on using a neural network to guide a system called cvc5. So, before we dive into the neural networks themselves,
Right.
could you give us a quick overview of cvc5 for those who might not be familiar?
Of course. cvc5 is one of the best systems out there for solving what we call SMT problems. That stands for satisfiability modulo theories, if you want the full name.
Hmm.
But it's basically like a really powerful logic solver.
Yeah.
You give a logical statement,
Okay,
and it figures out if that statement is true or false.
makes sense.
But it can take into account all sorts of background information like, rules about arithmetic or data structures.
So it's not just dealing with abstract logic, it can actually work with real-world math concepts.
Exactly. And what's really impressive is how well cvc5 handles problems that even other advanced systems like E and Vampire struggle with. It's a real powerhouse, even before we start adding neural networks into the mix.
And that's what makes this research so intriguing. Using AI to help another AI solve logic problems, it's pretty mind-blowing.
It is. It really shows how fast both fields are moving.
Definitely.
Now, to understand how they're doing this, we need to talk about something called proving by instantiation. It's a key technique that cvc5 uses.
From the research, it seems like this involves substituting variables in logical expressions, right?
Yeah, you've got to basically you start with a statement that you want to prove or disprove.
Okay.
And that statement might have variables in it, kind of like placeholders for different values. So the goal is to find specific values for those variables.
I see.
We call them instantiations.
Okay.
And these instantiations either make the statement true or they cause a contradiction, which proves it's false.
So it's like trying to solve a riddle where you have to fill in the blanks to either make the statement make sense or make it completely fall apart.
That's a really good analogy.
Yeah.
And cvc5 has a few different ways to find these instantiations, each with its own strengths and weaknesses.
Like what?
Well, there's the enumerative method, which is basically like trying every key on a giant key ring until you find the one that unlocks the door.
Sounds a bit brute force.
It is, pretty much.
Okay.
Then there's E-matching, which is more sophisticated.
Okay.
It looks for specific patterns in the statement, kind of like recognizing the shape of the keyhole to narrow down which keys might fit.
So it uses clues from the problem itself to be more efficient.
Exactly.
Mm-hmm.
And lastly, there's conflict-driven instantiation, which is all about finding those quick wins. It looks for substitutions that immediately contradict what we already assume to be true.
Interesting.
Yeah, it might not find every solution, but it can be really effective in certain cases.
Gotcha. So where do neural networks fit into all of this?
That's where this new research comes in. It uses something called a graph neural network, or GNN for short, to guide that enumerative instantiation process we talked about.
Okay, now we're talking. I'm really curious. How do you even represent a complex logical problem to a neural network so that it can understand it?
That's the clever part. They represent the problem as a graph, where each node is like a piece of the logical statement, and the edges show how those pieces are related.
So it's like creating a visual map of the logic problem for the neural network to analyze.
Exactly. And what's even cooler is how they train the GNN. They feed it a bunch of successful proofs that cvc5 has already found. And specifically ones found using that E-matching strategy. And the idea is that by learning from these successful proofs,
Yeah.
the GNN can start to predict which substitutions are most likely to lead to a solution.
Fascinating. So they're using the results from the more sophisticated E-matching technique to teach the GNN how to guide the simpler brute force enumerative method.
You got it. And that's where we start to see some real power. Instead of just trying every combination randomly,
Right.
it gets some guidance on where to focus its search.
That makes a lot of sense. So did they see any actual improvements using this GNN approach?
Oh, yeah. They tested it on a huge set of problems from the Mizar mathematical library.
Okay.
It's like a massive digital library of formalized mathematics. And get this, the GNN-guided approach was sometimes over twice as fast as the standard enumerative method.
Wow. That's a huge improvement. Solving those complex math problems in half the time. That's pretty incredible. Could you maybe tell us a little more about the Mizar Mathematical Library? I'm not familiar with it.
Oh, sure. It's basically a giant encyclopedia of mathematical proofs, but they're all written in a language that computers can understand.
I see.
It's been used in theorem-proving research for decades. It gives a standardized way to test and compare different approaches, so these results are really significant.
That makes sense. So it's not just some random collection of problems. It's a well-established benchmark, which gives these findings real weight.
Exactly. And there's another detail I think you'll appreciate.
Hmm.
The GNN ran entirely on a single CPU. No fancy, expensive GPUs required.
That's great. It makes this technology much more accessible, right?
Exactly. It's not just a theoretical advancement. It has real-world potential.
It sounds like it. We're talking about speeding up mathematical proofs, but I'm wondering, could this have applications beyond just pure math?
Absolutely. Think about software, for instance. Programs are essentially logical systems at their core, right?
Right.
So this approach could be used to find bugs and vulnerabilities in software much faster. It's like having an AI assistant helping you debug your code.
That would be a game changer. No more spending hours combing through lines of code. You could have an AI point you right to the problem.
Exactly. And it doesn't stop there. Think about scientific discovery, where researchers are always looking for patterns in tons of data.
Yeah.
This can help them make connections and find insights that they might have missed otherwise.
It's like having an AI research assistant working alongside scientists.
Exactly. And that's what excites me most about this research. It gives us a glimpse into how AI can really enhance our ability to solve all sorts of complex problems.
I agree. This has been an incredible deep dive so far. But before we move on, I have a question.
Oh.
You mentioned that e-matching was still better on this particular Mizar beta set. So if e-matching is already so good, why even bother with this GNN approach?
Yeah, that's a great question. And it's important to remember that while e-matching might be the best for this specific data set,
Right.
there are other kinds of problems where it might not be as effective. And in those cases,
Okay.
the enumerative approach, especially with the help of this GNN, could be much more competitive.
So it's like having a specialized tool that you can pull out for specific jobs where it really excels.
Exactly. It's all about having the right tool for the right job. And this GNN gives us another powerful option.
This is what I love about these deep dives. It's not just about understanding the research itself, but also about thinking about what it could lead to, the potential applications in other fields.
Oh, absolutely. And speaking of those applications, maybe we should dive a bit deeper into how this GNN was designed and trained.
Absolutely. I'm always curious about the behind-the-scenes stuff. What were some of the challenges they faced in designing and training this GNN?
Well, one of the biggest challenges was figuring out how to represent those logical statements in a way that the GNN could actually understand.
Makes sense.
As we talked about earlier, they used a graph-based representation.
Right.
But designing that graph, making sure it captured all the nuances of the logical relationships, that was crucial.
So it's not as simple as just feeding the raw logical statements into the neural network?
Definitely not. There's a real art to preparing the data and making sure the AI can actually grasp the structure of the problem.
I see. What about the training data itself?
Well, remember, the GNN needs to learn from successful proofs. And they actually used e-matching to generate this huge data set of proofs, which they then fed to the GNN.
So they use the more sophisticated strategy to teach the GNN how to guide the simpler one. That's kind of ironic when you think about it.
Yeah, it is. It's like the students surpassing the teacher. But they also had to be really careful with the training process itself.
So, oh, yeah.
Figuring out how to reward the GNN for making accurate predictions
Yeah.
and how to tweak its parameters over time, it's all very intricate.
It's amazing how much work goes into creating these AI systems. It's a real testament to human ingenuity.
Definitely. Now, one thing I found really interesting was that even though the GNN was trained to guide this enumerative process,
Right.
it actually ended up trying fewer substitutions than the standard enumerative mode. It was less prolific, so to speak.
Really, that's surprising. You'd think an AI system would just try even more combinations than a brute force approach.
You would, but that's what makes this finding so interesting. It seems that the GNN, because it had learned from all those successful proofs,
Right.
it was able to make more informed choices about which substitutions to actually try.
Ah, so it wasn't just randomly trying everything. It was using its knowledge to focus on the most promising options.
Exactly. And that's why, even though it tried fewer things overall,
Yeah.
it was still able to get those speed improvements. It's like it developed a sense of strategy or intuition.
It almost sounds like the GNN is learning to reason in a way. But how can we be sure that it's not just some clever statistical trick? Is it really developing a deeper understanding of the logic?
That's the million-dollar question. It's hard to know for sure what's going on inside those neural networks. They're a bit of a black box.
I know what you mean.
But these results suggest that it's learning something more than just correlations. It seems like it's actually extracting some deeper understanding of how logical arguments work.
So while we can't peek inside its brain directly, it does seem like it's learning to reason, at least on some level. That's pretty amazing.
It is. And it shows that these AI systems can learn to be more efficient than just blindly trying every possibility, which has some big implications for how we design and train AI in the future, I think.
Absolutely. This has been a mind-blowing discussion so far. So much food for thought.
I agree. It's been a pleasure.
But before we get too carried away, I think it's time for us to take a little break. We'll be right back to continue exploring this fascinating topic. Welcome back to our deep dive into the world of neural networks and automated theorem proving. Before the break, we were discussing those impressive results with the GNN-guided cvc5.
Some really promising stuff.
Definitely.
Uh-huh.
But before we jump back into the technical details, I kind of want to zoom out for a second and think about the bigger picture.
Okay.
We've touched on how this technology could be used in other fields,
Right.
but I think it's important to remember how fundamental logic and reasoning are to pretty much everything we do.
Absolutely. We use those skills all the time without even thinking about it.
Right. They're the basis of science, engineering, even art and music in a way.
I agree. It's how we make sense of the world.
Exactly. So when we build AI that can help us solve these complex logical problems,
Yeah.
it's not just automating tasks, it's like we're expanding our own ability to think and understand.
I like that. It's like we're creating tools to help us think better, deeper, more creatively.
Right. And as we talked about, those tools could revolutionize so many fields.
Oh, definitely.
But we also have to be realistic. There are potential downsides to consider too, right? Like any powerful technology, it could be misused.
You're absolutely right. We always need to be thinking about the ethical implications and make sure these tools are used responsibly.
For sure. For now, though, I want to focus on the positive potential. Going back to the research, one thing that really stuck with me was how the GNN-guided approach actually tried fewer substitutions overall,
Oh, yeah.
but it still got those speed improvements. How is that even possible?
That's what makes this finding so intriguing. It shows that the GNN isn't just blindly trying every single option. It's actually learning to be more selective, more strategic.
It's like it's developing an intuition for which paths are most likely to lead to a solution, right?
Exactly. And that's how it can achieve those speed gains, even though it's trying fewer things overall. It's a great example of how AI can sometimes be more efficient than just brute force.
But how do we know it's not just some statistical trick? I mean, is it really developing a deeper understanding of the logic?
Well, that's the big question, isn't it? It's hard to say for sure what's going on inside that black box of a neural network.
I know what you mean.
But the results suggest that it's more than just statistical correlations. It seems like it's actually grasping some deeper understanding of how logical arguments are structured.
So while we can't exactly see its thought process, the evidence points to something more profound than just number crunching. It's learning to reason, in a way.
It really does seem that way, doesn't it?
This is pretty amazing. It shows that these AI systems can learn to be more efficient than just blindly trying every possibility.
Exactly. Which could have big implications for how we design and train AI in the future. Instead of just throwing more data at the problem,
Right.
we need to focus on teaching AI to learn more effectively, to be more strategic in its approach.
That's a great point. This has been a fascinating discussion, but I want to shift gears a bit and talk about the bigger picture again.
Okay.
We've talked about specific applications in software development and scientific research,
Right.
but this feels like just the tip of the iceberg. I mean, we're talking about a fundamental shift in how we solve problems.
Absolutely. We're moving beyond just programming computers with fixed rules.
Yeah.
We're teaching them to learn, to adapt, and to guide us towards solutions we might not have found on our own.
It's almost like we're creating partners in the problem-solving process, not just tools.
That's a great way to put it.
So let's speculate for a bit. What are some other areas where this AI-guided problem-solving could have a big impact? What are you most excited about?
Well, one area that comes to mind is medicine. Imagine AI systems that could analyze medical images with superhuman accuracy, spot patterns in genetic data that humans would miss,
Right.
or even design personalized treatment plans based on an individual's unique biology. It could completely change how we approach healthcare.
That's amazing. It's not just about assisting doctors, it's about opening up entirely new possibilities.
Exactly. And it doesn't stop there. Think about environmental science.
That?
We could use AI to model complex ecosystems, predict the effects of climate change,
Wow.
maybe even come up with strategies to mitigate those effects. It's about understanding our planet on a deeper level and finding sustainable solutions.
It's like giving us a new lens to view the world and the challenges we face.
Exactly.
Yeah.
And then there's education. Imagine AI tutors that adapt to each student's learning style,
Yeah.
providing personalized instruction and feedback. It could revolutionize how we learn.
I love how you're emphasizing the collaborative aspect, the idea of humans and AI working together to solve these big problems.
That's what it's all about. It's not human versus machine, it's human plus machine.
Right.
It's about combining our strengths to create something truly extraordinary.
I agree. But with all this talk about the potential benefits,
Yeah.
I think it's also important to acknowledge the risks.
Yeah.
Any powerful technology can be misused, right?
You're absolutely right. We need to be very careful about how we develop and deploy these systems.
Yeah.
Remember, AI is only as good as the data it's trained on and the goals we set for it.
Right.
If we're not careful, we could end up with AI that perpetuates harmful biases or makes unfair decisions. We have to be very mindful of the ethical implications.
It's a reminder that technology is never neutral. It reflects the values and intentions of the people who create it.
Exactly. We need to make sure that AI is used to benefit everyone, not just a select few.
I think that's a perfect note to end this segment on. We've covered so much ground today.
It's been great.
From the nitty-gritty details of this research to the big picture implications for problem solving and the ethical considerations we have to grapple with.
A lot to think about.
It is. But before we wrap up this deep dive completely, I want to leave our listeners with one final question to ponder.
Oh, I'm intrigued.
If AI can already help us with these complex logical problems, what other challenges might be within our reach? What other breakthroughs could be just around the corner? We'll be back after a short break to explore these final thoughts.
Welcome back to the deep dive. I'm still thinking about all the possibilities we talked about before the break.
Me too. It's amazing to consider what might be possible when we combine human ingenuity with the power of AI.
Exactly. And that's what I really want to focus on in these last few minutes.
Okay.
We've talked about this research, how it's pushing the boundaries of automated theorem proving, and even touched on potential applications in other areas.
Right.
But what I find most fascinating is the bigger picture. The idea that AI can help us reason and solve problems in ways we never imagined before.
Absolutely. This research gives us a glimpse into a future where AI isn't just about automating things, it's about making us smarter, more capable.
And that's what I want to leave our listeners with today. If AI can already help us with these incredibly complex logical problems,
What other challenges might we be able to tackle? What other breakthroughs might be just around the corner?
that's a great question.
Mm.
And I think the most exciting part is that we don't really know the answer yet. The possibilities are practically endless.
So let's speculate a bit.
Yeah.
What are some areas where you think this kind of AI-guided problem solving could really change the game?
Well, we talked about medicine before, and I think that's a prime example.
Definitely.
Imagine AI that can analyze medical images with incredible accuracy,
Yeah.
way beyond what humans can do.
Right?
Or systems that can spot patterns in genetic data, patterns that we might completely miss.
Yeah, or even design personalized treatments based on a person's unique biology.
Exactly. It's not just about assisting doctors, it's about creating a whole new level of healthcare.
I agree. It's about taking things to the next level.
Right. And what about environmental science? AI can help us model those complex ecosystems, predict how climate change will affect different regions,
Mhm.
and maybe even come up with ways to reduce those impacts.
Mhm.
It's about understanding our planet in a whole new way.
And finding solutions to some of the biggest challenges we face.
Exactly. And then there's education. Personalized AI tutors that adapt to each student's individual needs.
Oh, yeah.
That could be revolutionary. Imagine a world where everyone has access to the best possible education, tailored just for them.
That's a powerful vision. I love how you're highlighting the idea of collaboration between humans and AI. It's not about replacing us, it's about empowering us.
Absolutely. It's about humans and AI working together to achieve things that neither could do alone.
That's the key takeaway here. It's not human versus machine, it's human plus machine.
I love that. It's about harnessing the strengths of both to create something truly amazing.
And that's a message I hope our listeners take to heart. As we wrap up this deep dive, I want to encourage everyone to stay curious, keep exploring, and keep pushing the boundaries of what's possible. The future of AI is incredibly exciting, and it's up to all of us to shape it in a way that benefits everyone.
Well said. It's been a pleasure joining you on this deep dive.
The pleasure was all mine. Thanks for listening to The Deep Dive. Until next time, stay curious.